right. So oh my. Hold on. There you are. All right. So if you look at choice board for week 7 that we had we did the word problems for it, but it says to watch an activity on a measurement from a playlist. Not yesterday, Monday, I told you guys to look at the activities. We looked at several activities on customary measurement. Even though we're not supposed to actually learn that in 4th grade, I feel it's important because here in the United States, we still use the customary system of measurement. So today we're going to look at the metric system of measurement. We use it in some aspects here in the United States, but everywhere else in the world. And I think most of you will either have a job that uses metric system, or you're traveling to places that use metric system, or even when you're watching I'm about to sneeze, television, you'll hear them use the metric system of measurement. I'm going to first try to play you a video, and it's going to stop because my password and login for vocabulary is on the computer at school. So it's going to stop in the middle of the song, but it's still, you'll get the gist of what they're trying to say. And it's a helpful way to remember the prefixes of the metric system. Because with the metric system, when you're dealing with units of measurement, you have the base, and the base for measurement of length is meters. For water or liquids substances, for measuring volume, you use liters, and when you're measuring weight, you use grams. But that's what when you hear them in the song yell base. But this is an easy way to remember the prefixes. Because all the prefixes in a metric system mean something.
You know, I figured out how to memorize the metric system. It's all based on powers of 10. So you just need to memorize a couple Latin prefixes, and then you can measure anything. Just remember King Henry. Oh, you don't know about King Henry? Listen up. King Henry died drinking chocolate milk. 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 It goes kilo, hecto, deca, deci, centi, milli, weight, kilo, hecto, deca, base.
See, I told you it was going to turn off. But an easy, fun way of remembering the prefixes in the metric system is King Henry, which was the actual king of England, died drinking chocolate milk because he was really chocolate towards the end of his life. And it stands for, King stands for kilo, Henry stands for hecto, died, it stands for drinking, base. Drinking is deca, chocolate is centa, and milk is milli. And whenever you're using each one of the prefixes, you in order to get the different units of measurement, you have to go. It's a base 10. If you're going from the smaller unit in size to a larger unit in size, you divide. If you going from a smaller unit size to a larger unit size to a smaller unit in size, you multiply by 10 on each step. And if you're going from from the base to like kilo, you multiply by 1,000. We'll go over that a little bit later. I'm also going to show you the brain pop video, which gives you another explanation for the metric system.
Sorry, all they had left in the fridge was chocolate milk. Hey, what gives? King Henry doesn't usually drink chocolate milk? Yes, I know it's a metric thing, but what does that have to do with anything? Dear Moby, help. There are too many metric units. How can I remember them all? Thanks, Jorge. Oh, hi, Jorge. You know, it might seem like there are a lot of units in the metric system. That's the decimal-based measurement system used by most of the world. But if you look closely at these units of length, you'll see that they're really just variation in the same unit. That's one of the beauties of the metric system. You can scale any measurement up or down just by changing the unit's prefix. For length, that unit is the meter. For mass, it's the gram. And for volume, most people use the liter. Well, you could measure length with nothing but meters, but that's not very practical when we're talking about, say, the length of a human hair or how far it is to the next town. To measure something that's much larger or smaller than a base unit, it's easier to tack on a metric prefix. The prefix creates a new unit that's a power of 10 bigger or smaller than the base unit. For example, a centimeter is 1/100th as long as a meter, perfect for measuring that hair. And 1 kilometer equals 1,000 meters, ideal for measuring that road. How many prefixes are there? More than you're ever likely to use. But don't stress about learning all of them. Really, you just need to memorize the 6 most commonly used prefixes. And, lucky for you, Moby has the perfect way to do just that. Just memorize the sentence, King Henry doesn't usually drink chocolate milk. The first letter of each word stands for a different prefix, except for usually, which is just a placeholder for whatever base unit you're using. Well, we already know that kilo means 1,000 and centi means 100th. As for the others, hecto means 100. Deca means 10, deci means 1/10, and milli means 1,000th.
All right, so if it's on to if you were thinking of a number and it's a larger or a whole number, you start here as the base unit and you multiply by 10 each way. So if it's here and you want to go to a hectometer or a hectoliter, you would multiply it instead of by 10, you would multiply it by 100. And if you were going from the base unit to centimeter, you would multiply it by a decimal or a fraction of 10. That's where you got the 10th place, the 100th place, or the 1,000th place, which you got the THS on the end.
Notice anything about these values? Right, each prefix is exactly 10 times as big as the one to its right, and 1/10 as big as the one to its left. It makes it a breeze to convert from one unit to another. I'll show you. Let's say you want to figure out how many milligrams are in 5 hectograms. On our handy prefix line, Put your finger on the unit you're starting from. Then count the number of units your finger passes while moving to the unit you're converting to. 1, 2, 3, 4, 5. Now, take your number and move the decimal point the same number of places in the same direction. And you add a 0 for each place the decimal moves. There you have it. 5 hectograms is the same as 500,000 milligrams.
Now, if I'm saying 5 hectograms, and I am saying 500,000 milliliters, milliliters are like, if you just take 1 milliliter, it's way, way, way smaller than a hectoliter. Because it takes 500,000 milliliters to make up 5 hectoliters. Or it takes 5,000 milliliters to make 5 liters.
Yes, it really is that simple. Just remember that King Henry doesn't usually drink chocolate milk. Good to go. I guess this is an unusual night for King Henry.
All right, we're going to solve a few of them. And just imagine, all right, set of okay. Now, kilo is at the top of a staircase, and each time you go down one to get to that prefix, you have to divide that many times. All right. So to get from a kilometer to just 1 meter is the base, you're going to divide by 1,000. So, oh wait, no, excuse me. You're going to multiply that many. Okay, so 7 kilometers equals how many meters? So you're going to say 7 times 1,000. How many is that?
7,000.
7,000. Okay. Now let's look at the next one. You got 13 liters. Liters is the base. Centimeters is farther down the stairs 2 times or 100. So you're going to say 13 times 100 equals to how many centimeters?
1,300.
1,300. Now this one looks a little different. All right. Now you got 88 decameters, right? Decimeters. All right. And so you got kilo, hecto, deco with the O, base, deca, which is this one right here, centi, milli, weight. So if you got 88 of these, and then you have only 8.8, that means you slid the decimal over 1 this way. So that means you divide it by 10s, which means you're going backwards up 1. So 88 decameters, if you go backwards, is actually the base. not meters, that's grams, right? So that's actually going to be 8.8, not deca, just plain, not decagrams, just plain old what? What's your base here? Grams, yeah. So you got 8.8 grams equals to 88 decagrams. All right. Now, blank hectometers equals to 102 meters. So if you imagine you're going up the stairs, and if you start up the dog, if you start up the stairs, you're gonna start with your decimal behind the 2 and the 100, right? Behind the 2 and 100, right? That means each time you go up the stairs to a prefix, you're going to slide your decimal over. So you go from meters to decometers, you slide it one time. You go from decometers to hectometers, you slide it one more time. So here in the blank, you're going to write 1.0 1.02, which is hectometers, which is 1 200 of a meter. I think this is a little bit much for you guys to bite off. Let's try it. Let's try just simple basic conversions. All right, remember, we're going to do just one set of conversions at a time. It takes 100 millimeters to make 1 centimeters. So if you're going from millimeters to centimeters, you are going to divide by 100. If you are going from centimeters to millimeters, you're going to multiply by 10. So that's actually 10 here. All right, so 80 millimeters is how many centimeters? You're going to say 80 divided by 10. So what's
10.
80 divided by 10?
8.
Yes. So it takes 80 millimeters to make 8 centimeters. Now you have, if you go from 11 centimeters to millimeters, you're going to say 11 times 10. What do you get?
110.
Keep going. 100 and what? Keep going. 100 and what?
10.
10. Correct. All right. Now you're going to go with 250. This time you're going from milliliters to centimeters. So this time you are going to divide by 10. So 250 divided by 10 equals
25.
25. You just cancel the 0, correct? All right, so this time, meters, which is our base unit, we're going from meters to centimeters. And that means we're going down the steps. All right, if you go down the steps, you're going to go from base, down to deca, which is times 10, to centimeter, which is times 100. So if I had 100 centimeters, how many, if I had 1 meters, I just gave you an answer. How many centimeters do I have? 1 times 100 equals
100.
All right. This time we're going backwards. We're going out, which is smaller in size, but is more in number. 400 to meters. So you're going to say 400 divided by 100 equals to?
4.
Thank you. This time we're going to have 15 times 100 equals?
1,500.
No, just 15 times 100.
1,500.
What you said? Oh, you said 1,500 or 1,500. I think somebody said.
1,500.
Yeah. Now you got 2,200 or 2,200 divided by 100 equals?
22.
Thank you. Now, it's super, super small. It takes 1,000 liters to make just 1 liter. And liters is in the base unit place. All right, so 1 liter equals to how many milliliters? If you multiply 1 times 1,000.
1,000.
1,000 milliliters. I'm saying it like that because it's so small. All right, if you had 7,000 liters, how many liters do you have? So 7 divided by 1,000 equals?
7.
Or 700.
7,000 divided by 1,000 equals?
7.
Thank you. This time you got 12 liters, the baby. And you want to go to liters, which is the smaller unit. 12 times 1,000 equals?
1,200.
Somebody said it. Not 1,200. It is 12,000 because you want to add 3 zeros to the 12. All right, now 36,000
What?
divided by 1,000 equals 2.
Because I think there's more measurement. There's more units in between here. Like if you divide by, it just depends on how many.
36,000 divided by 1,000 equals 2.
36.
36.
36. Yes. And remember, from when you were learning to divide and multiply base numbers by zeros, you just take, if you got 3 zeros in 1,000 and you divide it, you just take 3 zeros away from the number and get your product or quotient. Or you give it 3 zeros. All right, grams is the base, and kilograms is even larger. It takes 1 of the kilograms, which is really, really, really larger, and it takes 1,000 of whatever the base is, which is the base is gram. So 1 kilogram times 1,000 equals to what?
1,000.
1,000. Now, this time, since you're going up the stairs, you're going to divide. You're going to say 5,000 divided by 1,000 equals to?
5.
5, yes.
5.
Now, this time you're going from kilogram, which is the bigger number, to grams, which is a smaller number. You're going to say 8 times 1,000 equals?
8,000.
8,000.
8,000. All right. Now the last one, you got 9,000 grams, which is the base. And you want to make it to kilograms. Are you gonna multiply or are you gonna divide by 1,000? Are you gonna multiply or are you gonna divide by 1,000?
Divide.
Divide. So 9,000 divided by 1,000 equals to
9.
9. Correct. Remember, if you're going up from the base to a larger number, it's larger in size, just like a fraction. It's larger in size, but it's tinier in number. But if you're going down the stairs, it's larger in size, but it's smaller in number, but it's smaller in size. Okay? You'll get more practice in converting numbers using a metric system as you go out the year, and you're going to especially use it in 5th grade next year because it's working with decimals a lot. Any questions? All right. Now it tells us to watch Tomlin Zooms. It's called Grammar Lessons on the Cloverleaf webpage. We're gonna do the one that is called possessive nouns. Possessive nouns. My computer's running super slow, so.
Miss Ferrell, I have a question.
Sure.
For the box under math, we already do complete learning activities for a measurement playlist on the Cloverleaf.
That's the one we just did. The metric system.
Okay.
That's the one we just did.
I did say that.
All right. That counts in that box. And the activity was that sheet and then the brain pot activity.
Okay.
Now,
Miss Farrell,
yes, dear.
which one was the one that we just did?
It's the one in the first column from math that says watch a video from the 3rd grade activity in the measurement.
Okay, thank you.
Now this one is the one in the 2nd column that says watch one of Miss Tomlin's grammar activities.
Noun is a person, place, or thing. And today we're going to talk about possessive nouns. So this is a noun that shows that something is owned by someone or something. So an example would be the dog's bowl. So the bowl belongs to the dog. Or the girl's dress. Okay, so the dress belongs to the girl. What do you notice about these nouns? So dog and girl. What's different about this?
All right, now, right here is just one dog. and one girl. And how do you show you're writing the sentence saying that the dog owned the bowl? You put an apostrophe, this symbol here is called an apostrophe, up a little high above the last letter of the word, and you add an S to it. And that shows that the dog owns the bowl, or the girl owns the dress. All right, now, let's see. Let's go with who can give me like a general noun? Any general noun?
Her,
That's a pronoun.
they,
They.
Cat.
Cat. All right, if I have cat, I would add an apostrophe S. And I'm going to say it's milk. All right, so I know that is that cat, that one cat, milk. And I would say this sounded cat's milk. Or I would say oh, that's disgusting. All right, the cow hide, I would say apostrophe is hide. That's that one cow, and that one cow owns the hide because it's on its body. All right. Now if you have
one's a human and one's an animal.
They have an S. Okay, so this is what's showing that it's possessive, okay, that it owns something. All right. So possessive nouns have an apostrophe. Okay. So Dad's car and Mrs. Smith's class. Okay. Nouns that don't end in an S.
now if a noun does not end in an S, you add apostrophe S, you add an S, and if it's just one person on it, you just add the S in it. Now, if it's more than or if it's more than one person owning it, like a group of people, like the Colts, and they own a field. But it's I before E. And they owned a field, I would put the apostrophe S. I mean, excuse me, I would say put the S so you know that it's more than one.
Okay. Her name ends with a Y. Okay. After the S. So ants belongs to Ryan. How could we make that possessive?
All right, now I know that it's more than one coat because like all of us are coats. I'll say coats, and I put the S after. I put the apostrophe after the S, and that means that we all own the field. Like if you're a part of a family, and I want to say the Millers, because it's more than one of you in that family, I would say the Millers. And I would put the apostrophe after the S, and I would say house. Millers, because it's more than one. And then I would put the apostrophe after the S and then write what they own. Okay? Now, look at the thing right here. The room belongs to Ryan. How would I do that? Do I put apostrophe S or S apostrophe? If the room belongs to Ryan, Ryan is how many people?
Pay attention.
Is he one.
One.
Or more than one person?
One person.
One person. So I would say
You
Ryan, Y-A-N, apostrophe S. Okay? Because Ryan is one person and he owns the room. Okay? Now listen to the other one. Book that belongs to library. Just one library. How do I write that? Do I write apostrophe S or S apostrophe?
apostrophe S.
Apostrophe S, yes. All right, if I say the jury belongs to the girls. There's an S on the end, so is that one girl or more than one girl?
More than one girl.
More than one girl. So I would say, would I say apostrophe S or S apostrophe?
S apostrophe.
S apostrophe. Great. Now, if the cats, C-A-T-S, if the cats have a book, it's toys, is that more than one cat or just one cat?
More than one cat.
So do I say apostrophe S or S apostrophe?
S apostrophe.
S apostrophe. Now is mom phone. If mom has a phone, is mom one person or more than one person?
One person.
One person. So do I write S apostrophe or apostrophe S?
S apostrophe. Not me.
Apostrophe S. Because it's just one mom. So as you are writing from now on, and you are writing a noun, and your noun owns another noun in that sentence, make sure you are showing that noun has possession with apostrophe S and S apostrophe. And I would tell you now, Miss Ferrell has a hard time with S's. Because if you watch that video of the coats of the teachers, I said coats instead of coats. I left the S off. My bad. I didn't proofread my own writing. But be aware of apostrophe S and S apostrophe when it's appropriate in your writing. Any questions?
Yes, I have another question.
Sure.
How someone's name ends from NAS?
Like my name? Oh, gosh. Like if I was saying Ferrells, that's me as a family. But if oh my gosh. Do I have anybody that name?
Dr. Seuss.
Like Dr. Seuss?
Yeah.
Who ends in an S? You just put you put another apostrophe S. Because if you put
Please stop.
Because if you did not put another apostrophe S in the end and just landed there, it means you're saying that it's more than one of him.
Okay.
That's a hard one. But that's a good question. Now, remember from the last lesson about plural and proper nouns? And it's the same thing with plural possession and proper possession. Where a proper noun, you start, it's like your name. And make sure you add either S if you're just talking about you, or if you're talking about your family, you don't add the S, you just put the apostrophe at the end. Okay. Now in the third column,
Ow.
all right, in the third column, it talks about the food chain. And we know that the food chain is, oh my, that's a dead link. The food chain is like a series of animals that if you took one of them away, everything else would die. For example, birds eat worms. Worms eat dirt. Dirt comes from the earth. Like, what if you had bad dirt that didn't have worms and the birds didn't have anything to eat? The birds would disappear. Or in the ocean, the shark is at the top of the food chain. And if the shark had nothing to eat, it would become extinct if the fish that the shark eats didn't have anything else to eat. Oh wow. Okay. This is going slightly crazy. All right, now you could go on the Cloverleaf webpage and look at videos from the Cloverleaf YouTube page and look at videos about the food chain. I was hoping to show it to you here, but my internet decided it's gonna act a little bit foolish. But we know it's like a circle. Like a food chain is one needs the other one in order to survive. It's like if the bees, because y'all have you heard in the news about these killer Asian bees that's going around? Like if all of a sudden those not bees, they're wasps. If those wasps took out a whole hive of honeybees, and we depended on those honeybees to pollinate our plants, and our plants did not get pollinated, that means that we would not have a food source because the honeybees were taken away. Even though bees are like, ow, and they hurt when you sting them, they're a necessary part of our food chain because it helps pollinate. It's not coming up. So I'm sorry about that. So go investigate the food chain for this week. Any questions? All right, I was telling Stephanie and Stephanie and Denelsi was here at the time, that at the I went yesterday and started packing up the classroom, but your stuff won't be available to pick up until the 22nd. They're gonna call you in and give you your report card and your bag and stuff on the same day. So watch out for the connected. Maybe we don't get to see the food chain. Connect in on that. Friday we're having lunch, and you're gonna have a special guest.
Are we supposed to pick your stuff up tomorrow?
Huh?
Are we supposed to pick our stuff up from school tomorrow?
No. It's gonna be later on this month. Because they want you to come because report cards are not ready, and they want you to pick up your report cards and your stuff. And it was very interesting going through y'all desk. Y'all used to write a lot of notes.
A lot.
My name is Dr. Jeff.
What's up, Jeff?
Are you a living thing? If you are, we should totally talk because we have a lot in common. In fact, you and I both have a lot in common with all living things. Your teacher, trees, your pet parakeet, bumblebees, everything. And one of the most important things is we all eat. Everyone needs food, which is why one of the best ways to learn about life on Earth is to follow the food. See where it comes from and where it goes while living things are eating. Here are the basics about the flow of food and the energy it contains, making life possible. Let's start with a simple question. Why do we have to eat in the first place?
We need energy.
We all eat, right? But have you ever wondered why we eat? I mean, some animals only eat plants. Others just eat other animals. And some creatures eat both plants and meat. But the thing is, all animals, including humans, eat. And we don't just eat because we're hungry or bored or tired or it tastes good. Although I could really go for a slice of pizza right now. We eat because we need food to live. More exactly, we need the energy that food gives our bodies to grow, move, and stay warm. You've probably figured this out already from the things you've heard about how and when we eat. Like, you've probably heard that breakfast is the most important meal of the day. Or you might know that runners will carb load before a big race. But food is necessary for all living things, all the time. You may have noticed that your collection of cool rocks that you have under your bed never needs a lunch of club sandwiches and baby carrots. That's because they're non-living things. But food is most definitely a necessity for animals, and plants too. Even though we don't think of plants as eating, because they don't have mouths, they still need food to grow and repair themselves, just like we do. In fact, plants make a nifty model that can help us understand how the energy from food affects living things. To see how food affects plants, we can can test what happens when they get more or less food. Plants get most of their food from the sun, water, and carbon dioxide in the air. More on that another time. But to test how food affects plants for yourself, you can use liquid plant food. That way you can control how much food or nutrients the plant gets. So consider this little investigation. Say you have 2 little plastic cups filled with potting soil, and you planted a lima bean seed in each one. Then you give each plant a different amount of food. Plant number 1 would be your control. That means you don't give it any additional food at all, just a little water and sunlight, and it'll do what plants do, all on its own. Then you can make plant 2 your extra food plant. Ask your parents for some liquid plant fertilizer and add the recommended amount to plant 2. Now, if you kept watering and feeding your plants the same amount for, say, 4 weeks, what do you think? Would you expect both of the plants to grow the same amount, or would one grow more than the other?
Now, when that one plant gonna receive extra food, what happened?
It will die.
It would die?
Yeah, because it's gonna be.
It would grow big.
If so, which
You
ones?
think it's gonna either die or grow big?
Well, what you'd find is that plant 2
Grow
is bigger
big.
than plant 1, because living things need food to give them energy, so they can repair themselves and stay healthy, and in this case, grow. So with more food, plant 2 got more energy, and that allowed it to grow bigger. Now go eat your vegetables. Okay, so food is energy. Plants can make their own food, while many animals wipe the energy from plants by eating them. But what happens to that energy once it gets eaten up? Well, you might say that it gets all tangled up in a food chain, and you are part of it. Not everybody likes the same kind of food, right? That's probably a good thing. I mean, all the more pizza for me. But whether we eat milkshakes or mangoes, pizzas or pears, tacos or toast, we use the energy that's in our food to stay alive. But how did that energy get into our food in the first place? The answer is that energy flows between living things. It's almost like each form of food is a link in a chain. A food chain. You might have heard that humans are on the top of the food chain because we eat pretty much everything, and except for the occasional video game monster and maybe the odd bear, nothing tries to eat us. But what is a food chain exactly? A food chain is a model that shows how energy flows between living things. You can think of animals and plants in the same food chain as all living in the same neighborhood, which scientists call a habitat. And they all have a job to do, interacting with each other day in and day out. Together, they form a kind of system, a self-contained collection of different things that all work together as a whole. And they also interact with the non-living stuff around them, like the water, the air, the ground, and the sun. Put it all together, and what do you get? A special system called an ecosystem. And food chains show us what eats what in an ecosystem. Now, everything that's alive is in a food chain, including you, my friend. And actually, most living things are in more than one food chain, depending on what or who they're munching on at the moment. I mean, you don't eat the same thing for dinner every night, do you? Didn't think so. Now, let's see how a food chain works by making a diagram of how these interactions happen in nature. First, all of the energy that's in a food chain starts with the sun. I can't stress that enough, people. Plants take the energy from the sun's rays and change it into chemical energy. So when a nice patch of lush green grass starts to grow, it's capturing some of the energy from the sun to do it. Then when an animal, like a rabbit, wanders by and nibbles on that grass, the energy from the plant is transferred into the rabbit's body. Now, if a hungry hawk decides that the rabbit would make a yummy supper, then the energy from the rabbit is transferred to the hawk. And in this ecosystem, nothing is large or brave enough to take on the hawk. I mean, just look at her. So we've hit the top of the food chain, and we've just made a nifty model of it. So a food chain is a model that shows how energy flows between living things in an ecosystem. Energy in a food chain starts with the sun, which is turned into chemical energy by plants. And this energy moves up the food chain as animals eat the plants, and then other animals eat those animals. And speaking of energy, I'm starving. So I'm off to take my place in the food chain. See you next time. So, a food chain is really a model of how energy flows among living things in an ecosystem. But in the...
All right, so you saw there how the sun provided the plants fed the rabbit fed the hawk was the top of the food chain. But then the waste from the hawk or sometimes go back into the soil and it fertilizes the soil again. Example, like the same thing with cows. The sun provides the hay or grass. The cow eats the hay or grass. We eat the cow.
Eat more chicken.
We process the cow, or the cow processes the grass and back out. And that fertilizes the soil again so it can grow more food for the cow. So it's like one big circle or a chain that goes around. One part of the chain depends on the other part of the chain.
What if the cow stops fertilizing?
Then the energy that went into the soil will have to come from another source. Have you ever heard of people talking about they compost stuff?
Yeah.
All right, when you compost things, you take things that are wasteful and you turn them together to where they provide an energy form, and you put that back into the soil as a type of fertilizer.
My grandma does that to the potato skins.
Oh, yeah. That's a good example.
And my apple skins.
Yep. And it's some of the seeds that you waste go back in to replant another plant.
Even the cob on a corn.
Yeah. Because yeah, I talk about my grandpa a lot, the one from Florida who had the farm. We wasted nothing. I mean, like you said, the corn on the cob, we fed it to the pigs. And what we did, we ate the pigs. You know, anything that you thought wasteful, like the scraps from your meal, we fed it to the animals. And then we ate animals. So go ahead and watch more videos about the food chain, or as you go about your life, think about how the things that you eat, what part of the food chain did it come from? All right. I'll see you guys on Friday.
Wash your hands. Be safe. And be nice to your siblings.
Yeah, to your family and one another.
Okay, bye.
All right, see you guys on Friday.
See ya.